Hi everyone. This week we will actually be introducing the formal system that we will use to understand the validity of arguments. So let me switch to my slides. Now in this unit, so for the rest of this unit, so for the next month or so, the two main things that we'll be looking at for our formal system are the syntax and the semantics of propositional logic or truth functional logic, PL or TFL for short. So over the next 2 weeks, we're going to be studying how to translate sentences of English into sentences of our formal language, PL. And so in order to understand what a sentence of our formal language is, we have to look at the syntax. So the main purpose of this lecture is to introduce to you the syntax of our formal logic. And that will be what really matters over the next 2 weeks when we really focus on translation. But the thing with semantics is that it kind of builds on syntax. So in order to understand the semantics, we have to have syntax in place. So that's why, and starting in a few weeks, we'll be turn to the semantics. But I will also in this lecture give a brief introduction to the semantics as well to foreshadow what we will be eventually looking at. So in this video of the lecture, I'm going to be introducing the syntax, and in the next video of this lecture, I will be introducing semantics. So again, this is the overview. Also, I'll be dealing with syntax in this first video, and then in the next video, I'll be talking about the basics of semantics. So our formal language, propositional logic, PL, in the readings is talked about as TFL for truth functional logic, okay, but these are abbreviations for the same thing. So PL is a formal language that comes with its own special symbols. So first we will use uppercase letters to stand for atomic or simple sentences. So we'll have these uppercase letters, any letter of the alphabet in uppercase. So A, B, C, D, E, F, G, etc. And in addition, we'll also use uppercase letters with subscripts of numbers just to make sure that we have enough. In addition to uppercase letters that stand for atomic or simple sentences, we also have special symbols called connectives. Another word you'll see for this is operators. But these special symbols, connectives, help us create complex sentences on the basis of the atomic ones. And finally, in addition to atomic sentences and connectives, we also use parentheses or brackets as well. So what is the syntax? Well, the syntax of a logic specifies what counts as a sentence in that logic. Another more technical term for a sentence of a logic is the notion of a well-formed formula. So when we give the syntax of a formal language, what we're doing is we're specifying very precisely what exactly it means for something to be a sentence in that language. Now, in general, what counts as a sentence in a given logic is whatever can be constructed in the appropriate way from its vocabulary. So you should think of the simple uppercase letters like A, B, and C, and the connectives, which we'll see in a second, and the parentheses as the vocabulary. So it's kind of what those things are the basic building blocks which you have. And then what we're going to do is we're going to give rules for constructing further sentences out of those building blocks. And what counts as a sentence in our logic will be whatever can be constructed in this special way from these building blocks. So the syntax of propositional logic specifies what is a sentence of PL. So it specifies what is a sentence of that logic, or again, a WOF or well-formed formula. By giving about vocabulary and a way of building sentences out of it. So specifying a syntax for our logic involves giving a vocabulary and a way of building sentences out of that vocabulary. And that's exactly what we'll see right now. So again, the vocabulary of propositional logic, or PL, is as follows. First, we have the basic / atomic sentence letters. So just simply A, B, C, and then we have to understand these dots here mean that we're including basically any other sentence letter. And then we can also use subscripts if we want. And then in addition to the basic sentence letters, we also have the connectives. And there are 5 connectives that we will be using. In this table, I list the symbols for the connectives as well as a brief explanation for what they are. So the first symbol is the symbol for negation. And we will often see either this symbol here, this hook, or the tilde used, okay? And whether you use the hook or the tilde, it doesn't matter. They're equivalent, and these are symbols for negation. And this negation translates the English word not. The second symbol is for conjunction, and similarly here, it's also often you'll see people use one or the other of 2 different symbols. On the one hand, there's this kind of cap or kind of thing, and then there's also the ampersand. So both of these symbols are equivalent symbols for conjunction, which corresponds to the English word and. Third, there is the symbol for disjunction, which is a kind of V, and that corresponds to the English word or. So, but as we'll see, as we start doing translations, there's many different English words that these symbols will translate. But the translation I'm giving you here is you can think of as a central English expression that this means, but there's also other ones that these symbols can be used to translate. So now fourth, there is the conditional, which is either expressed with an arrow pointing right or this horseshoe thing. And what that translates is a sentence of the form if ... then ... So as we've seen, the thing that goes in the first dots is the antecedent of the conditional. And the thing that goes in the second dots is the consequent. So for a conditional of our language, we put a sentence on the left-hand side of the arrow, which is the antecedent, and on the right-hand side, we put the consequent. Now the final symbol is the biconditional, which is an arrow pointing in 2 directions. And this translates to English, if and only if. Now, in addition to the basic atomic sentences and connectives, there are the parentheses or brackets. So the 3 things I've listed here exhaust what we call the vocabulary of our formal language. So these are the basic building blocks out of which we will be able to construct any sentence of our language out of. So in addition to, after giving this vocabulary, we're now going to see special rules for constructing out of these building blocks sentences of our language. And the definition or these rules might seem a bit intimidating at first because it is what's called by mathematicians a recursive definition or an inductive definition. Now, it's important that when I talk about this definition being inductive, I don't mean inductive in the same sense as we talked about the other week for probability. This is rather a special notion of induction. And let me try to walk you through what it means. So as I've already stressed, when we're trying to define what it means for something to be a sentence of our logic, we first specify a vocabulary. And then we specify rules for building sentences out of that vocabulary. And the idea is then that what it means for something to be a sentence of our language is for it to be possible to build it out of the vocabulary using these rules. And the rules are precisely the ones that you see on this slide. So the first rule simply says that basic sentence letters are themselves sentences of our logic. So any of these basic or atomic sentence letters, A, B, C, D, etc., itself counts as a full-fledged sentence of our logic. So again, you can just have a simple sentence letter A, which stands, for instance, for it's raining, or whatever you've chosen for it to stand for, given your translation manual. That basic sentence can itself be a sentence. Whereas, for instance, if you just put a parentheses, that's not a sentence of the language. Or if you just put a conjunction sign, that's not a sentence of the language. So the first rule tells you that you can take a basic sentence letter, and by itself, it's going to be a sentence of the logic. The second rule of ours for constructing sentences is as follows. If phi is a sentence of our language PL, then so is not phi. Now, the immediate question you might have is, why am I using this fancy Greek letter phi? Well, the reason is precisely because this definition of what it means for something to be a sentence of propositional logic is a recursive definition. And what that means is that it includes rules that apply to themselves. And the use of this variable allows this rule for constructing negative sentences to be applied to itself. Well, what does that mean? Well, suppose we begin with the sentence letter A. By the first rule, we know that A is a sentence letter. We know that the sentence letter A is a sentence of our logic. And so because we know that A is a sentence of our logic by the first rule, we can then apply the second rule here to infer that not A is a sentence. So we've just applied our first rule B and the rule for negation to infer that the sentence that you have a sentence not A. But then what if we want to construct the sentence not A? Well, what we do is we apply this rule for negation to the sentence not A. So in this case, we think of phi as standing for not A. And since we know that phi is a sentence in this case, since we know that not A is a sentence, we know according to this rule that not A is a sentence. So because this rule says for anything phi which is a sentence, so is not phi, this rule can be applied to the things which it itself helps determine as being sentences. Similarly, with a rule for conjunction, it says that if phi and psi are sentences, then so is phi and psi. So if for any two things you have, phi and psi, that you can show are sentences of your logic, then you can put them together with the conjunction sign. And similarly for disjunction, if you have two sentences, phi and psi, then you can put them together with the disjunction sign in between them. You can also do this with the conditional sign and the biconditional sign. And the final rule says that nothing else is a sentence of propositional logic. That is, that the only sentences are things you can build up by repeated applications of these rules. And the fact that we're using variables in the rules for negation, conjunction, disjunction, conditional, and biconditional allows us to recursively apply these rules to their own products. Now, the crucial thing to note is that these variables phi and psi, they're never themselves sentences of the logic. Now, this is a subtle point, but it's very important that you understand this point in order to understand why it is that we're using these variables and how they work. So this definition tells us that to begin, basic sentence letters like A, B, C, etc. are sentences of our logic. And then, given that we have these sentence letters as sentences, we can recursively apply these rules to those sentence letters to build up complicated sentences. So in no case, according to these rules, do you have it that something like just simply phi, or phi and psi, or not phi, or phi if and only if psi. You never have it that that itself is a sentence, because the rules only say, for instance, if phi and psi are sentences, then phi if and only if psi are sentences. And the cases in which this antecedent is satisfied, where you have phi and psi as sentences, ultimately boils down to beginning with sentence letters. So any single sentence of our logic is made up of sentence letters connected with something like negation or conjunction or disjunction. So you will only ever see as sentences sentences that contain sentence letters and the connectives. These variables, phi and psi, do not ever actually appear as sentences of the language. Rather, they're simply being used here to say that, to stand for any arbitrary sentence, which we have to do in order to specify the rules recursively. So, as explained above, sentence letters like A, B, and C are and make up particular sentences of our logic. And I want to stress what I've just said, which is that I do use the Greek letters like phi and psi in similar ways. So we do say, for instance, if phi is a sentence, then not phi is a sentence. But that does not mean that these Greek letters are sentences or that they ever make up sentences. Rather, they're variables that are being used to quantify over sentences of our logic. As variables, they denote arbitrary sentences of propositional logic, either simple or complex. And that's exactly how these rules are able to be recursive rules. That's exactly how we can apply this rule twice to tell us that not A is a sentence, because we start with A, which is a sentence, and then we apply this rule once, which tells us not A is a sentence, and then we apply it again, which tells us not A is a sentence. So when we say if phi is a sentence of PL, then so is not phi, this phi has to be either an atomic sentence letter or anything else which we've built up as a sentence. But we can never actually build up phi itself as a sentence. Phi only ever stands for other things that we build up according to these rules. So again, something like phi and psi are variables which denote arbitrary sentences of our logic. So when we talk about phi and psi, we're actually talking about arbitrary sentences where phi is replaced by a particular sentence letter or a sentence. So we're talking about, for instance, the sentence A and A, or the sentence B and B, or the sentence C and C. So all these three sentences here, these are actual sentences of our logic. Whereas the sentence phi and phi, that is not a sentence of our logic. Rather, it's standing for a whole bunch of different sentences where phi is replaced by particular actual sentences. So to elaborate this further, because this is a crucial point that you have to understand, you have to understand the use of variables in our logic. So to further elaborate this, I want you to consider the difference between the argument in A and the argument in B. So in A, we have a simple kind of representation of what we've called modus ponens. So we have as a first premise, if phi then psi. We have as the second premise phi, and we have as a conclusion psi. Now in B, we have something very similar, which is that we have as the first premise, if P then Q. We have as the second premise P, and then the conclusion Q. So in order to understand the difference between these two arguments, you have to understand that A is not actually a particular argument, but it's rather an argument schema. So what A represents is that whichever sentences you plug in for phi and psi, you will arrive at a particular argument in our logic, which is a valid argument of the form of modus ponens. So what A is giving us is a form of argument. It's saying whichever sentences you plug in for phi and psi, you will get an argument of this form modus ponens, which is a valid argument form. Now, on the other hand, B is a particular argument because we're using particular sentence letters. So you can think of the difference as B is what we arrive at from A, where we say that we'll instantiate the variable phi as P and instantiate the variable psi as Q. And so if we think of phi and psi as specified in that way, then we have the argument B, which is of the form given by A. So B is an argument which actually does contain sentences of our logic because we have atomic sentence letters, which are, we know by rule B, the first rule here, we know that basic sentence letters are sentences of our logic. So we know that P is a sentence, and we know that Q is a sentence. And then, given that we know that P and Q are sentences, we can apply the rule for conditional, which says that if you have two sentences, then you can connect them with the conditional sign. And that's how we know that premise 1 is also a sentence of our logic. So in B, we have an argument which is made up of actual sentences of propositional logic, whereas in A, we have a schema which represents a whole bunch of different arguments in our logic. And each of these different arguments can be created by plugging in actual sentences for phi and psi, and B is just one such way of doing so. So there's two more things I'd like to talk about in this video as an introduction to syntax. The first is parentheses, and then after that, I'll talk about scope. So in some cases, parentheses may seem redundant. So for instance, why, if you're just talking about a simple conjunction between two sentence letters, A and B, why would you write A and B in parentheses as opposed to just A and B? And in fact, in this case, adding the two parentheses around A and B is kind of unnecessary. So actually, we will usually avoid writing the parentheses, even though strictly speaking, we should, because if you look at the rule here, for conjunction, it says if you have two sentences, then combining them with a conjunction and putting brackets around them creates a new sentence. So strictly speaking, this is a sentence of our language, but this isn't. However, it seems kind of redundant in this case. So in this case, we'll drop the parentheses. But the reason why we do have parentheses hanging around is that they are sometimes necessary to disambiguate the scope of connectives, and I'll explain what scope is in 1 second. But you can understand the importance of parentheses just by considering the following case. I want you to compare the following two sentences. Here we have on the one hand, not A and B, and on the other hand, we have not A and B. So clearly these two sentences have a different meaning. This sentence is conjoining not A with B. And this sentence is negating the conjunction of A and B. Now, if we didn't have parentheses, it's unclear how we would be able to disambiguate or distinguish between these two different sentences. So when we have, in this case, it's important that we use the parentheses to indicate whether we are conjoining not A and B together. When we're saying that it's true that not A as well as B, or when we're negating the conjunction of A and B, when we're saying that it's not true that both A and B. So because there's cases like this, where parentheses are necessary, it's important that you use parentheses to disambiguate which you mean. Whereas in other cases, the parentheses are not necessary to disambiguate, and in those cases, we do not use the parentheses. So what I just said that parentheses are sometimes necessary to disambiguate the scope of connectives, and I illustrated that with this example. But you might ask, what is this thing I've just talked about as scope? So informally, the scope of a connective in a sentence is the part of the sentence surrounding the connective and contained by the nearest pair of parentheses. So what does that mean? So for instance, I want you to consider this sentence here, A and B or C. So here in this sentence, we're disjoining, or we have a disjunction of C on the one hand, and the other disjunct is A and B, the conjunction of A and B. So when we ask what is the scope of the connective, the and in this sentence, the scope is just this one disjunct A and B. So the scope of a connective in a sentence is a part of the sentence that surrounds a connective and contained by the nearest pair of parentheses. So here, if we're wondering what the scope of the conjunction, we look at the part of the sentence that surrounds it and is contained by parentheses. And then if we ask about the scope of the disjunction, we can see that it's the entire sentence. So as a quick illustration, we can ask what are the scopes of the various connectives occurring in the following complex sentence, which we would read as follows. If A or B, then not C and D. So first, the scope of the disjunction is the antecedent of the conditional. So the scope of the disjunction is this sentence A or B, because that is the part of the sentence that is surrounding the disjunction and contained in parentheses. Now, if we ask about the scope of the conjunction here in the consequent of the conditional, we see that the scope of this conjunction is the entire consequent. So it includes not C and D. Now, if we ask what is the scope of negation, in this case, that has to be thought of a bit differently, as I've said here, and the scope of the negation is, in this case, just the sentence letter immediately following it. Okay, so the negation here is simply just negating C. So the scope of negation is just C. And the scope of the conditional is the entire sentence. Okay, so what we think this sentence is a conditional sentence. The conditional is the main connective. And what the conditional is doing is connecting two other sentences, first a disjunction, and then second a conjunction. And the conjunction involves a negation. So that way of understanding this sentence involves thinking about the scope of the various connectives in it. Okay, so what I want to do is talk to you about some terminology, just to briefly summarize some terminology that we've used to talk about the sentences of our language. And then we'll go over a few practice examples to determine whether certain strings of symbols are sentences. So to summarize some terminology which we've already been using, so sentences of the form phi and psi are called conjunctions. So when you have this wedge symbol, or a kind of a hat symbol, That stands for conjunction, and so when you have it conjoining two sentences, you call that overall sentence a conjunction. And you then call the constituents phi and psi. Each of them are called conjuncts of the conjunction. Now, similarly, when you have a sentence of the form phi or psi, that sentence is called a disjunction, and the two constituents phi and psi are called disjuncts. When you have a sentence of the form if phi then psi, that is called a conditional, and phi is called the antecedent of the conditional, and psi is called its consequent. Fourth, sentences of the form phi if and only if psi are called biconditionals. Phi is called the left-hand side of the biconditional, and psi is called its right-hand side. Now finally, sentences of the form not phi are called negations, and you can simply call phi, in this case, the negated sentence. So that's just summarizing some important terminology and ways of talking about the sentences of our formal language. And now, to conclude the video, let's go through a few examples, and I'll talk through whether or not these examples are examples of sentences or not. So to begin, we start with the basic sentence letter P. Is that basic sentence letter P a sentence of our language? And the answer is that yes, it is. P is a sentence of our language because, as if you recall, the very first rule of what it means for something to be a sentence of our language says that basic atomic sentences are sentences. Now consider another sentence letter A. Is that a sentence of our language? And the answer is yes, for the exact same reason that P is a sentence, because A is an atomic sentence letter, and again, the very first rule of what it means for something to be a sentence is that atomic sentence letters are sentences. Now here I have just a single bracket, or parentheses. Now is that single parentheses a sentence of our language? The answer is no, it's not. So the parentheses is used as a part of the vocabulary, and it does show up when we construct complicated sentences using the connectives. But nowhere in these rules does it say that you can simply have parentheses and that count as a sentence. The parentheses only are included when we're constructing complex sentences using the connectives. So you'll never have simply a parentheses standing by itself. Now, what about if you have two parentheses with nothing in between them? Is that a sentence of our language? The answer in this case is no, it's not. So this looks maybe a little bit less crazy than this does. The third one, just a single parentheses, but nonetheless, it is not a sentence of our language. So to return to the rules, again, these rules only introduce parentheses when they're surrounding complex sentences which we have built up from the basic sentence letters and connectives. So the parentheses will never occur just by themselves as a sentence. So these rules do not let us build just simply two parentheses with nothing in between. Now, what about this? And this is a bit tricky. Is phi and psi surrounded by parentheses, is that a sentence of our language? Now the answer is that no, it is not. Phi and psi is not a particular sentence of the language, and the reason it is not is because it's using sentence variables. So phi and psi stand for arbitrary sentences. They are not themselves sentences. So similarly with, like if you're just thinking of basic math, the number 9 is a number. The number 11 is a number, but the variable x itself is not a number, it's a variable for numbers. And similarly, phi and psi are variables that stand for different sentences, like for instance P and A, but they are not themselves sentences. And this might be hard to understand because in our rules for building up sentences, what we say is that, for instance, if phi and psi are sentences, then so is phi and psi. So it seems like we're saying here that phi and psi is a sentence, but it's important to understand that this rule is a conditional and it says if phi and psi are sentences, then phi and psi is. And the only cases in which we can apply this conditional are cases where phi and psi are themselves built up out of basic sentence letters. So whenever we apply this rule, the phi and psi stand for particular sentence letters or things built up out of them. And that is why you never get that phi and psi is itself a sentence. Phi and psi are always going to be standing for particular sentence letters. So this here, phi and psi, is not a sentence of our logic. Rather, it stands for an arbitrary collection of sentences where you stick in a particular sentence for phi and a particular sentence for psi. Okay, so is the sentence P and Q a sentence of our logic? Now the answer is yes. So we don't require the parentheses because we're going to be relaxing that restriction because they're unnecessary in this case. And here we have a conjunction between two sentence letters. And this is a sentence of our language. Now what about this? P and Q or R and S. Is that a sentence of our language? Now the answer to this is yes, it is. This is a sentence of our language. So it might be a bit hard to see how this can be built up from our rules, but it can be by applying several of the different rules. So first we begin by noting that P, Q, R, and S, those four things are all sentences because they're sentence letters. So the very first rule tells us that these are all sentences. And then since we know that P and Q are sentences, we know that P and Q is a sentence. And since we know that R and S are sentences, we know that R and S is a sentence. And since we know those two things are sentences, we know by the rule for disjunction sentences that we can put them together in a disjunction. So we can construct this sentence by applying the rules that I gave above. And so we know that this is a sentence. Now, is this a sentence of our language? If P, then chi. So X, or chi here, which looks like a fancy X, is the fancy Greek letter, which is similar to phi and psi. So this is chi here is a variable in the same sense that phi and psi are variables. So is the sentence, if P then chi, is that a sentence of our language? And the answer is that no, it is not, because chi is not a sentence of our language. It's a variable that stands for arbitrary sentences. So similar to how phi and psi is not a sentence, if P, then chi is not a sentence either. Now, finally, is this a sentence? If P, then P or Q. Now the answer is that no, this is not a sentence. And the reason it is not is because it's violating our rules for when we have to include parentheses. So there's two ways of, so this sentence as I've written it is ambiguous. It's ambiguous between the case where the parentheses go around P, if P then P, so you could have two parentheses around this conditional here, or you could have parentheses around the disjunction P or Q. In whichever way, whether you do it either way, you'll get a different sentence. So you can't just write, for instance, if P then P or Q without putting parentheses around one part of the sentence, because we have to disambiguate whether it's a conditional with the antecedent P and a consequent P or Q, or whether it's a disjunction with one disjunct as a conditional if P then P, and the other disjunct as Q. So this here is not a sentence of our language because it is not adequately using parentheses. So in the next video, I will quickly go over an introduction to the semantics of our language.